Okay, for the domain of a composite function, we have to consider really two separate domains. The domain of the input function, which in this case is g. So that one's pretty easy to figure out. We take the denominator and we say that cannot be 0, right? You can't divide by 0, which means x cannot be 8. So they want us to use interval notation, so that means I would start at negative infinity, go to 8, skip 8, and then go from 8 to positive infinity. Okay? That is the domain. This is not the domain. This isn't the answer. This is the domain of G. Why are we finding the domain of G? Because when you find the domain of a composite, you always start with the first function. You do the g of x thing first. So first you have to consider the domain of G. Okay? So that's part of our answer. We're going to have to combine this domain with the domain of the actual composite function. So the composite function, f of g of x, means into f, 1 over x minus 6. I'm going to plug in g, which is this whole function, 1 over x minus 8. So now we got to deal with this complex fraction. This isn't an easy one. This is a tough one. Because I got to remember how to deal with complex fractions. I got a fraction within a fraction. So what we do is a trick we do in math a lot is multiply by the little denominator, right, which is x minus 8. So in the numerator, and it'll kill this I don't want this fraction within a fraction, okay? So if I do this method, I shouldn't have to, we'll have to distribute in the denominator. I won't have a fraction anymore. So up top, x minus 8 times 1 is x minus 8. And in the bottom, when I multiply x minus 8 times 1 over x minus 8, I just get 1. That's multiplying a number by its reciprocal. And then I have to multiply the 6 by x minus 8. And then we'll simplify, combine some like terms. Distribute the negative 6 plus 48. And that equals x minus 8 over 49 minus 6x. Okay, this is my composite function. So normally you might ask yourself, well, if I want to find the domain of a composite function, find the composite function, find the domain. And that's what we did, but we just have to consider this starred guy over here. So we found the composite function. Now what's the domain of this? Same approach. The denominator cannot be 0, so 49 minus 6x cannot be 0. And I solved that guy, so 49 cannot be 6x. Divided by 6x cannot be 49 divided by 6. Kind of a weird number. So my domain is, if I didn't have to write it in interval notation, my domain would be all x values, but it cannot be 8 and it cannot be 49 over 6. I could just say that. But the computer wants me to go interval notation, so I have to start at the smallest number, go to the next biggest one, which is 8, union that, and then the set from the next biggest number, 49 over 6, which is a little bit bigger than 8, so sorry, go in order. 8 to 49 over 6. 8 to 49 over 6. Right, that's 8 and 1/6, I believe. And then I go from that to infinity. Everything else is okay. And that is how I write my domain. All numbers, but 8 and 49 over 6 in interval notation looks like that.